Energy resources are large stores of energy that can be used to generate electricity and heat homes and businesses. In this video, we're going to talk about electricity and how it is generated and the different energy resources that makes electricity generation possible. And then we'll also look at the various options available, the advantages, the disadvantages, and a few environmental issues surrounding this energy generation resources. And yeah, it's a global issue, not just an issue in the UK or an issue in the US. It is what every country faces. And then we'll look at what influences the decisions of the government in terms of what energy resources to choose from. So stick around while we dig into it. Energy resources, the large stores of energy, we talked about that, and then the list is endless. I mean, the list of energy resources we have in the world available to us in the 21st century is endless. Electricity, all right, how is it generated? Now listen up. The basic process for electricity generation is the same for every resource. The energy source turns the turbine, and then the turbine turns the generator, and then the generator produces electricity. It's as simple as that. And we have a couple of examples, like hydroelectricity. You have mechanical energy from water turning the turbines, kinetic energy, and then the turbine turns the generator, and the generator provides the electricity needed. As simple as that. For power generation, using fossil fuels, because fossil fuel is another option that can be used. For fossil fuels, well, it contains chemical energy, right? So the chemical energy in fossil fuels, you have different ones. You have oil, you have coal, you have natural gas. So the chemical energy there heats up the water, providing thermal energy. So the thermal store of the water increases, and that by extension turns the water into steam, and the steam turns the turbine, and then the turbine turns the generator. Can you see the pathway now? The same, with just minor differences. Now, when we're talking about fossil fuels, the pathways, like I said, you have the chemical energy stored from the fuel. Back in the days, coal was used to generate electricity, but now, mostly in the UK, gases are used. So let's just use the general term fossil fuel. So when the fossil fuel is burnt, the thermal energy goes into the boiler. So chemical energy converts into thermal energy, and then that goes into the boiler. The boiler turns the water into steam, and then the steam turns the turbine, and you know the rest. If we were to talk about nuclear, you can see how we've grouped these guys on the screen. We have water power, steam power, geothermal, and wind power. That would help you to remember in an instant. So for water, you have hydroelectric and tidal. Now, we'll come back to that. Let's talk about geothermal for a second. For geothermal, it is another way to produce steam that turns turbine. And what happens with geothermal? Well, it uses the energy from the rocks. Hot rocks underground will heat up water. The water will turn into steam. Can you guess the rest? The steam turns the turbines turns the generator, and electricity is generated. And then we can use the geothermal to also heat homes. You know, the water will be pumped around fissures as steam, and homes will be heated. Enough of that. Nuclear power. Well, nuclear power is non-renewable. Why did we say it is non-renewable? Come to think of it, Nuclear reactors use either uranium or polonium in some cases, or sometimes thorium in extreme cases. Polonium in itself is a very scarce natural resource. Now, from the use of the word scarce, there, yes, it is non-renewable because you don't have it in abundance. It takes millions of years for it to be produced. And that will take us to the steps or the pathways. So, nuclear energy goes into thermal, heat is generated, and then the heat generated provides the steam that turns the turbines, and then the turbines produces the electricity. Same thing. You have wind power, same pathway as well. Kinetic energy from the windmill, made possible by the wind, turns the windmills, and that turns the turbines, producing electricity from the generators. As simple as it may seem. Okay. And then these guys, they're divided into renewable and non-renewable. Okay. Now, if it's renewable, it means it is replenished at a faster rate than it is being used up. It's not going to run out, no matter how much of it you use. Starting with solar energy. Solar energy comes from the sun, obviously, and the sun has been around for billions of years. So that is, you can't use all of the sun. It's going to take billions of years before you run out of the sun, before it goes to a red giant, and you know the rest, and then till the end of the life of that particular stuff. That's a discussion for another day. Renewable resources, they're very, very good. But you might be thinking, if renewable resources, if they're this good, if they don't contribute to the carbon emissions, why are we not using them? Why aren't we replacing all the non-renewable resources with the renewable ones? Why? Well, there are a couple of issues. Number one, for solar energy, it requires a lot of land to fix the solar panels. That's one. Two, on cases where there is no sun, not like there is no sun, but there are so many clouds that the sun couldn't get through. And if at that point in time, the country or the state has a very high energy demand, what do you think will happen? There is no sun, no energy. And that's one of the reasons why, even for remote areas that uses solar energy, they always have an alternative in case it gets cloudy. And then solar panels too can be sometimes very expensive to set up. Although to run it is almost at no cost, but to set it up sometimes can be very expensive when it comes to supplying large communities. For windmills, they're usually very, very massive. And sometimes they can constitute, well, we wouldn't call them a menace, but in terms of the landscape of a particular city, sometimes the government might not want windmills flying around. And to maintain windmills sometimes could be deadly. Yeah, there are various reports of, technicians getting on the windmill, trying to sort it out, and then the stuff blows up. There is no way for them to come down. It's a very sad situation. But that is just one of the issues. Another issue with windmill. Now, take this. This is not a campaign against renewable resources. We're trying to explain why we have not replaced all of the non-renewable resources with renewable. Just to answer some of the questions that a few of you might have. And yes, we're talking about the advantages and disadvantages. Advantage for most of them, yeah, they don't constitute to the carbon nuisance. And disadvantage in terms of reliability, maybe not so reliable. Still on the wind issue, on days when the wind speed is very high, the windmills will be making a whole lot of noise, which can disturb a lot of people. That's one. Two, on days when the wind speed is not so high, the windmills will not generate enough electricity. You see the issue there? Now, to biofuel, we can classify it as carbon neutral. There's actually a controversy concerning biofuel. And what's it? We make use of recent living plants to make the fuel. The carbon in them is extracted and then turned into fuel for transportation, for heating homes, and a bunch of other things. But some will argue that, yes, we're producing carbon. Well, by the time we use all of those things, they release carbon. Yes, they release carbon, but come to think of it, the source for that carbon was plants. So the plants acted as a store of carbon in the ecosystem. So the carbon was just taken from the ecosystem and returned back. So in terms of the difference, not much. Yeah. And then to produce biofuel, sometimes some countries might lack the expertise to do all of that. So they'll just switch to non-renewable resources and get it over with, because those ones are readily available and sometimes inexpensive. And then we have hydroelectricity. Now, hydroelectricity is pretty good, but then you need to set up a dam. The technical know-how to set up the dam is also something we need to talk about. If the dam is not built well, then flooding will happen, taking up human lives, taking up aquatic lives, and disturbing the whole aquatic ecosystem. And for the dam, hydroelectricity, sometimes it depends also on the rain. So on occasions where there is long seasons of dryness, of drought, to operate the hydroelectricity power system might pose an issue. And then the generation company might need to turn to other sources. And then we have geothermal. We've explained what geothermal is. One big issue with geothermal is the plants, they're usually very small and might not be able to supply an entire country. And not all countries, not all locations have those hot rocks that generates a lot of thermal energy like that. So, not readily accessible, also expensive. The technical know-how to also build it is not readily available in some countries. Build and maintain. Then you have tidal. Tidal, yeah, very predictable, but not very reliable as well. On days of low tides, yes, you see the issue. Now, for non-renewable resources, these guys, they're readily available. Talk of oil, available. Talk of coal, readily available. Talk of natural gas, readily available. Because most power generation companies now use natural gas, because natural gas produces less carbon than coal. And then you have nuclear fuel. Nuclear fuel produces large amounts of electricity, but if there is a nuclear accident, then you guess what will happen for hundreds of years? That area will be uninhabitable. A typical example was Chernobyl and a couple of others. And then expertise is also an issue there. But yeah, nuclear energy is very, very good. Natural gas, very good. But all of these guys, apart from nuclear fuel, produces a lot of carbon, which in turn causes global warming. But nuclear fuel, it doesn't produce carbon as much, but it produces a lot of toxic radioactive substances, which when it finds its way out, you know the rest of the story. Danger. Okay, now let's talk about the three main uses of energy resources. Just three: transport, electricity generation, and heating. fossil fuels as a whole, most times, is used for electricity generation and transport. Biofuel also will find itself in that category. Fossil fuels can also be used in heating homes as well. Apart from fossil fuels, we could also use nuclear energy, which is non-renewable. We could use wind, renewable, water waves, renewable, hydroelectric, renewable, solar, renewable, tidal, also renewable. Sometimes we also plug in water waves into it. And then we could also use geothermal, renewable. Now for transport, the majority of the vehicles in the world that are powered by petroleum products, such as petrol, diesel, and kerosene. And then you have aviation fuel in that category as well. That's also fossil. And then a growing number of vehicles are actually powered by electricity. Yeah, you have your Tesla and a couple of others. As good as all of those vehicles are, they're very fantastic. They're very fantastic. But they're also linked to the use of fossil fuels, because when you need to charge your car, you plug it into the mains electricity, the national grid. Now you see the link now coming from the fossil fuel. So you can see that we're still heavily reliant on fossil fuels. And then you have some vehicles also powered by biofuel. Biofuel is typically renewable. For those ones, we do not need to plug them into the national grid. Although, like we said earlier, that the claim that biofuels are carbon neutral is largely controversial. And then, yeah, for electricity generation, in the last 150 years, it has been like the center of human lives for more than a century now. With more than 8 billion people in the world, this means that the demand for electricity is extremely high. Now, can you see the reason why the renewable resources cannot keep up with the demands? Even though renewable resources, the carbon-free, we still have to go back to non-renewable resources to keep up that demand. Because virtually everything we do, 95% of everything we do in the world now relies on electricity. Name it. On the downside, the majority of the world's energy, 84%, still relies on carbon-emitting sources, non-renewable. And you know the issue with carbon-emitting sources, they contribute to global warming, which causes drought, causes climate change, and a bunch of other issues. So what you're seeing here is the primary global energy consumption. You can see fossil fuel contributes about 84%, nuclear contributes about 6%, renewables contribute about 10%. Now for the heating right here, most homes in cold countries are fitted with central heating systems. Now in the tropics, the countries in the tropics, well, they don't really need the heating system as much because, yeah, it's pretty hot. But in the temperate regions, the heating systems are needed. Now, the heating systems, they use natural gas to heat up water, and then that water is pumped around radiators through the home, which in turn will heat their homes. And then, unfortunately, as you might have guessed, the natural gas is a non-renewable energy resource. And in countries where, the landscape is geologically active, they tend to be very lucky to heat their homes using geothermal energy. Let's make some comparisons. Number one, fossil fuels. Coal. It's not renewable, but it's reliable. You can always get it anytime, any day. So let's just put fossil fuels generally in that space where you have coal. So all you have there is the same thing for them. The key advantages for that is, yeah, it is abundant, it is cheap, it is inexpensive. But disadvantages, yeah, it's got the highest carbon dioxide emissions there is, which is the major reason why global warming, climate change became an issue in the first place, especially going down from the 1800s, Industrial Revolution, all the way down to the current age. Solar energy is renewable. Is it reliable? No, because on occasions where it is really cloudy, you find it difficult to use it and then to meet up with the energy demands. But in terms of advantages, no carbon emissions is an infinite supply. Yes, the sun is infinite, only works in daylight. At night, no. But the problem here is solar energy can actually be stored. So during daytime, the energy is stored, and then if it's needed at night, it is used. But the question is that the same in every part of the world? Can everyone do that? Can all the governments of the world do that? Yeah, cost being an issue. Then you have wind. We've talked about wind as well. Only works when it's windy, sometimes sounds. There is a lot of sound, dropping out. Maintenance, also really important. Nuclear, not renewable, reliable. It produces a lot of energy in a short amount of time. No carbon emissions, very efficient, but a lot of radioactive waste is produced. Big question here is, why is nuclear fusion still an issue? Now, the thing is, to produce nuclear energy, the fusion reaction has to happen at a very high temperature, extremely high temperature, for the lack of a better word, and extremely high pressures. Now, while it is difficult to achieve these temperatures and pressures, it doesn't mean it is impossible. Yeah, it is very possible. But to maintain that extremely high pressure and temperature for a very long time, that the fusion reaction is required to continue, because when fusion happens, it also generates a lot of energy. So to contain that amount of energy is a very big issue, a very big one. And that means that only a very small amount of fusion can be allowed to take place. Yeah. So we're still a long way from where we'll produce more energy from fusion than the energy needed to start it. So the energy needed to start it, not really a problem, but the energy needed to contain it, that's where the problem is. And then let's move to the last part of our discussion here, which are environmental issues surrounding the use of these energy resources. Number one, main energy source switched from coal to natural gas over the years. So even for electricity generation, for heating homes, for transport, back in the days, it was just coal all through. Even for trains, coal. But now it has been substituted with natural gas and a couple of others, electricity as well. Government has also given grants to encourage the development of wind and solar farms. And remember, for wind and solar farms, they require a large number of land, amongst some other cost implications. And then a new generation of nuclear power stations are presently in development. Although with the old power stations being shut down, nuclear power is become like a small eruption in this entire thing. And then we also have other reductions of carbon emissions. And to achieve all of those things, we need to, the government will need to produce or set up more nuclear power stations to replace the existing fossil fuel stations, and then a means of storing energy from wind and solar will also need to be developed. Yeah, we have batteries, but sometimes the batteries might not store as much as what you want. Yeah, but maybe in the coming years there could be something else, even efficient batteries that can store large amounts at a reduced cost. Science can identify environmental issues arising from the use of energy resources. Number one, you have political issues. When you have a changing government, the new government might not want or might not choose the energy resource put in place by the previous government. Number two, social, the people, the culture of the land. Are they in support of it? Not. If it doesn't sit well with people, then the government has no choice. Ethical concerns. Nuclear power stations. Yeah, we've talked about it. We have to set up a lot of nuclear power stations, blah, 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 blah. But can the power stations be set up close to your homes? No. In the case of accidents, who will bear the greatest loss? You see where the issue is? Radioactive waste. Another issue. For hydroelectricity, flooding, or if the dam wasn't built well. We talked about that earlier. Then we have economic considerations. Cost. Every government tries to cut down cost as much as possible. So if there is a cheaper alternative, trust me, the government will go for it. So those are the concerns that determines what energy resource that particular country is going to use. And then from the chart you can see on the screen, the use of fossil fuel over the past 30 years has reduced from 75% to 38% in the UK, and the renewable energy usage has increased from 2% to 35%. And, other countries are also catching up. So you can see here, switching to gas isn't the solution, but it's a step in the right direction while renewable energy increases. It might take a couple of years before some of the issues surrounding renewable energy resources are solved. But for the meantime, we have to combine the two. So that'll be all for this particular video, and I'll catch you in the next one.